percentages. This also gets us into looking at exponential growth or decay, so that's a fairly powerful math tool we'll use. If you look under percentages, I have a, I'll show you. I have a little worksheet that goes over fractions and percentages. Will give you kind of an overview. So I'll leave those for you if you want to take a look. You can download the sheet, kind of make the fractions and such. Today I'm going to do something a little different that's more holistic and less into the fraction part of it. But let's see, so we're recording, are we? I believe. Good. And then we'll go over we'll work through the quiz together, but
the homework's not, like, for chapter 2 isn't due until Tuesday, right?
yeah.
Okay.
And if you need an extension, we could do it, but it's kind of try to follow the scheduling. So you'll see we're starting 3. So if you have 2 done already, that would be great. If it's not, you still have time.
Okay.
But just pace yourself so you don't get yourself where there's 2, 3, 4 sections to do, because this is a 5-credit class, but it's actually a 3-credit class with 2 extra credits for help. So the extra time. So they base the curriculum off of the 3 hours. So that's 3 hours a week of work in class, which when they do it means that you would have double that outside, so 6. So it should be about 9 hours worth of work. Some for you it'll be less, but the thing is if you get yourself 2 weeks behind, there's maybe potentially 18 hours to get caught up. 3 weeks behind, 20. So you can see how it doubles, it builds. Yeah. But so coming to class though, working through things, we get an extra 2 hours of class time that really is sort of built-in tutoring, built-in office hours. And that's where some of you are here, some of you aren't. That's fine. Okay, so let's go ahead and start in. If this is a block, and I tell you it is one block, one complete block, it's one thing, how would you describe that? How could you, what percentage do we have?
100%.
Very good. You're much faster than because I did a similar lesson this morning at ASU, and maybe they thought it was too obvious, but exactly, this is 100%. That's what it's everything. Okay. Now it might be a box that contains 50 things or 100 things, so we'll see how that relates, but it's a complete thing. It's 100% of what we've got. Okay. So if we make a copy of it, and we'll pretend that Little Crow drew a very accurate copy, this is also 100%. What if we cut it in half, and then cut the half in half, and I want to just focus on this much. How much do I have now?
25%.
25, 1/4 or 25%, right? Very good. So we always start, usually whatever problem we're starting with, we think whatever we start with is 100%, and we will either increase it or decrease it, or if we stay the same, that's the easiest problem, right? We have 50 students, and next semester we have 50 students, no change. But
this will be on Canvas, right?
The recording will be, yes.
What about the drawing?
Yes, because I'm recording.
Oh, okay.
So I record my screen, it gets my voice and whatever I draw in here. I was going to go to the board, but then that doesn't get recorded.
Oh,
okay. So let's think about this. Let's first look at what if we were losing, if I spell right, what if we were losing 25%? What would that look like?
Are we talking about of the block or
How much left?
Sure. How much would be left?
75%.
So that's this unshaded part here, right? So that would be 100 minus 25, 75%. And yes, it would be, we could draw this. Okay, and that's what we call exponential or percentage decrease, right? It's decreasing. How do we write 75% as a decimal?
0.75.
How did you do that?
It's kind of just a common knowledge thing.
Okay, that's what I told my wife too, but she didn't take that.
I guess what you do is you move the decimal point from behind or next to the 5 to in front of the 7.
So you moved it 2 places.
Yeah, you move it 2 places, and that's 0.75.
And the reason we can do that, that percentage, see the sort of 2 zeros divided, a percent is dividing by 100.
Gotcha.
Which moves the decimal over 2 places. But you're right, we get used to doing it, we just do it, we don't know why we do it. I'm a math teacher, I forgot why, my wife was taking a class like this and I was explaining it to her and she says, why? I don't remember, you just do it, right? So, yeah,
I love his response, it's just common knowledge.
Exactly.
It's the best response ever.
Okay, so 0.75. But here's what we can do. This is called what we call, in this case, this is a decay, means it's getting smaller, right? And it's a factor. What is a factor? A factor is something we multiply with. So we're going to think this process, if it happens multiple times, we continually will multiply by 0.75. So a 25% decrease, you want to think of it as a 75% left. Okay, so if I have a suit I want to buy and it's got a 25% off sale, I can also calculate that as I think of it as a 75% on sale. So if I multiply the price by 0.75, I will get how much I pay. I don't get how much I saved, but I get how much I pay. Okay, so there's kind of these 2 parts. The discount was 25%, but the amount that you will pay is 75%. Okay, so that's sort of one type of problem. The other type of problem we have is we're growing. We're not losing 25%, we're gaining 25%. What does that look like? Well, we start with our 100%. And what do we do with that 25%?
Add a separate block on top,
Add it on top.
and that would be 1.25.
So we'll emphasize that. And so then we have 125%. Which again, we got that from taking our 100% that we started with, and we're going to add 25%. So what does that give us? 125%. And what does 125% look like as a decimal?
1.25.
Okay, again, divide it by 100, or move the decimal over 2 places, however you want to do it, 1.25. Okay, so if we multiply, and this is what we call a growth factor. Okay, what happens when we multiply something by 1?
It's the same.
It stays the same, so nothing changes. So that's when, if we have a constant 100%, multiply by 1, we still get 5. But what if we multiply by 1.25? What's going to happen to what we have?
Increase the number.
It'll increase some amount. Can someone help me with that? What's 5 times 1.25?
6.25. I don't know.
I think you're probably right.
1.25 times 5.
Yes.
6.25.
You
Yeah,
were
that's
right.
okay.
Good job. My intuition's sometimes off. So we did get bigger, and we increased by 25%, didn't we? I mean, that's what was going on there. So what would happen though if we multiply by 0.75? Will we get bigger? Because
Smaller.
we're smaller. So we oftentimes think when I multiply, I get bigger, but in this case, because the number is less than 1, we actually get smaller. And I'll
3.75.
probably good. Where's my calculator? 0.75 times 5 is 3.75. Excellent. And that's basically what we're going to be doing today, is with percentages. Percentages, to get what we're going to calculate, notice I add to 100%, or I subtract from 100%. But then to get the amounts, I am multiplying. So with percentages, I always multiply by that decimal amount. Okay. And so the story here is, in all of these stories, we're starting with 5. This one is a constant, so no change. This one is a growth of 25%. We can kind of see, to get the growth amount, we'd have to subtract 1. And this one is decline or decay. Decay sounds kind of, I don't know, scary sometimes. Decay of 25%. Okay. So with that in mind, what if I did the same thing? I want to think of what's the percent growth or decay if I took 3 times 5. So I started with 5. I'm going to multiply by 3. What is the amount? What is the percent growth? And maybe think, how would we do that, right? When I had 1.25 times 5, I could figure out it was 25% growth. What did I do to figure out that it was 25% growth? Looking at that number. Decimal part. What did I do with the 1? The 1 disappeared, right? But how did that 1 disappear? What I really did is I took 1.25, I subtracted 1.00. So yeah, that's all that was. So if it's just 1 point something, those are easy to see. It's just the decimal part, right? But the process is because with 3 I'm going to need some help. There is no decimal part, right? So this tells me, okay, I have 25%. So could I do the same thing? I started with 3.00, and I'm going to subtract 1.00, or 100%, right? Because we always start with 100%. What's left?
2.
2.00. What's 2 as a percentage?
2%. 200%.
Right. Common sense. Just move the decimal the other way, right? So yes, so this is a 200% growth. So notice if I multiply by 3, that's 200%. If I multiplied by 4, what would that be? And yes, you're thinking right. Don't worry. Growth factor of 4 is a percent growth of the percent growth?
300%.
Good. We just subtract 1. We just subtract 1. So this would be a 300% growth. Okay? So that's the kind of thing, is when we're dealing with percentages, we're subtracting 1, or if we're given a percentage rate and we're growth, so we're either subtracting 1 or adding 1. I like to turn them into percentages and always do my addition subtraction with percentages. And then you can but that's, notice we're going both ways. We convert from decimals to percents and percents to decimal, so we need to use it, okay? Whenever we're multiplying, we've got to be sure we've got a decimal amount. So I wouldn't take 500 times 200, right? I take it times 3 and I'll get that's, I went from 5 to 15. That's a 200% growth, right? You can see the 5 is in there, and then there's another 5 and another 5. There's 2 more 5s in there. That's a total of, we now have 15. But the idea with percent growth is we've got something we started with and we get that back plus more. Or if we've got decay, we didn't get everything back, we're losing things. So a nursing problem, you give someone medicine and their body uses the medicine, so after time they've got less medicine in their body. That's a exponential decay. So
Thank you for relating it to nursing.
I tried it, yeah. My mom was a nurse too, so I helped her. I helped her with the math part. She helped me understand, but I couldn't help her with all those words you guys. Yeah, all those words, those Greek words or Latin words you have to learn. Oh, sorry. Yes, I respect you for going through that.
You're going to school to be a nurse, right? Oh, no.
So, with just that little bit of knowledge, less than 20 minutes we've talked, let's see how we do on the quiz. Because I think that's pretty much all we need.
Oh, okay.
Is that really it for this whole chapter? Are you serious?
Simple stuff.
That's awesome.
That's all.
Okay, because I'm like,
We've got a
looking
whole-
at all these and I'm just like, you just looked at all this.
Yeah, it's all that stuff.
I trust you.
I always get it down to just, we got the whole, we're gonna add. If you, yeah. So let's go ahead and, let's see if I can see all these. Let's see. I'm gonna make it, let's see if I can zoom in. How's that for you guys? Is it legible? Can you read it? Should I make it a little bigger? But when I make it too big, it might.
Yeah, no, yeah, that's perfect.
Okay, so we'll try to go to this. Okay, so here we go. A lender requires a minimum down payment of 16%. That's a percentage, right? So again, we haven't talked about mortgages yet, have we? But let's see how, all we're doing is applying percentages, right? You have $23,000 cash available to use as a down payment toward a home. Determine the maximum home value that you can finance. Okay, so we need a 16% down payment. We have $23,000 that we can use for a down payment. So how much house can we buy? So let's see how we can connect this, right? Here's the price of the house we can buy. That's 100%, right? How much down payment are we required to make?
16%.
16%. Which means we can borrow, because if we don't, we're not, yeah, we're not putting down, it was we're gonna borrow it. What percent are we borrowing?
84%.
Good, subtract 16 from 100, you get 84%. That's gonna be the loan. Okay, so the loan, this is loan. This is down payment. We'll just call it the down. How much money do we have for our down payment?
23,000.
So this amount equals 23,000. Okay. And then there's this amount here, which is going to be 84%. What we're trying to find, 84% of the total cost of the house. Actually, that would be the loan. But what we want is we want to know how much house we can buy. So we want to know what that 100% is, which will include the 23%. Well, since these two are the same size, right, could we use a proportion? What's a proportion? Yeah, so we didn't cover it directly. But a proportion is when you've got two fractions that are equal to each other, right? So if I have 3/4, I know that's equal to let's put it down here. I could say it's equal to, say, like 6/8, right? Because I multiply both by 2. What happens when I have a proportion? Have you ever done this before? What happens if we cross multiply?
Oh, yes, okay.
4
Now
times
it's coming back
6
to me.
is equal to 3 times 8. Right, they're both 24. So the nice thing about a proportion, and that's why we're going to use them a lot, is when a proportion is just two fractions that are equal. They look different, but they're equal. And what you get is when you cross multiply and take the top of one times the bottom of the other, you get two sides that are equal.
So we do the same with our, with like, say,
Yeah.
23,000 times like 84%, or in other words, like 0.84? Or am I thinking about it right?
We are going to do something like that. Let's see if I can get this out of the way. I guess I could put it over. So what do we want? We want the 100%, right? We want to figure out what 100% is. So remember, in every percentage, there's always 100, right? This is going to be what we want, the price of the house, right? That's the 100%. But what information do we have? We've got that 16% is the same thing as 23,000. Those things are basically equal in this situation. Is this a proportion now? It's two fractions. Of course, we don't know what the bottom is, right? We could put
Yeah,
it.
so we'll have to make that 16% a decimal.
Well, we'll do it as a percentage. What we're doing is when you take 16 divided by 100, it becomes a decimal.
Yeah.
So
yeah,
you could
so
do it that way. But I want to, and again, you could work it that way. But I'm also going to show you if you do it this way, kind of with whole numbers, what we end up doing is we're going to cross multiply 23,000 times 100. And then we would take 16 times x or something, but this is not an algebra class. So what we're going to do is, with a proportion, it will always work. I guess I'll come back up here. If let's focus on this part. If I take 6 times 4, which are across from each other, and I divide it by 3, so I multiply across and then divide by the odd one out. That's 24 divided by 3, which is 8. It's that missing piece. Okay. So when we get percentages, what I want you to do is we'll always have one set up where it's like 16% over 100%. We have our places over here, 23,000 times 100, and then what we just need to do now is divide by 16. Okay, and that's going to give us the 100% we need. So just kind of taking that picture and then
So that is 23,000 times 100 is the thing. And then
right,
divide that by 16.
and then divide that by 16. So it's kind of a process. It shows us the process.
So it's 23,000 divided by 16?
23,000
Or times 100.
times 100. And actually, order doesn't matter that much, but because you could have turned it to a decimal, and
Yeah.
but then it would be dividing by 0.16, right? So that's where
Yeah,
it's,
I don't like that
I know,
one.
it's, A lot of times, you're either going to multiply or you're going to divide. So a lot of times what I do is I'll do it, and I'll do it both ways, and then I'll see which number makes more sense, right? If we do it the wrong way, we get a smaller number, and it doesn't make a lot of sense. So does it make sense that if we've got 23,000 down, that the house we can buy, now it didn't get us the loan, but the house we can buy is going to be 143,750. And we put 23,000 and we borrow the rest. It seems about reasonable. Had I multiplied by 0.16, it would be like 16,000. Oh wait, I could pay cash for that kind of a house, you know. So it's let's see if we're right. 147.50. Okay. So we can do that same thing thinking of percentages as a proportion. When there's a missing piece, just set up a proportion. Some of you may have heard this. Another thing you can do with percentages is a proportion is a percent over 100 equals to is over of. Have you ever heard of that before? Somebody taught that. Another student. I never understood it. I'd heard it, and they explained how it worked, and that's basically what we just did. We have 16% over 100%. We have the down payment of the total house that we were going to buy. So this was the is part. This was the of part. And the other way to, instead of if is and of don't really make sense, you've got part over the whole. So those are the ways to think of it. So sometimes you don't want to draw that picture. 100% is always the whole. That's what we're looking. What would the whole price of the house be? 23,000 is a part. It's a 16%. So we can do that with a proportion. Okay. So far as making sense?
Mm-hmm.
Okay. Here's another one, different type of problem. Let me clear this stuff out. Do that. Okay. So there's two types of change that we have, and again, this will maybe look a little new, but we'll get a new formula. This problem, we're told a politician's support increases from 33% to 57%. They want what they call the absolute change as well as the relative change. Relative change just means percent change, so we'll talk about that secondly. So to get the absolute change, how much did the support change from going from 33 to 57? How do you think we would calculate that?
We do subtraction?
Just subtract, exactly. So we take 57 minus 33, 24. So that's a 24% change in the increase. So that's the easy one. But what about relative change? Relative change is, we kind of use this is the amount of change, but with relative change, it's a percent, and it's always, I'll give you kind of a formula to remember. Percent change we can get that by taking the new value minus the old, which we just did, but what we're comparing it to is the old value. So we divide by the old value, and that will make it into a percentage. And usually a decimal amount, and then if we want to take that decimal amount and make it into a percentage, what do? Multiply by 100. That thing just doesn't want to stay out of the way. Okay, so let's do that with this one. So percent change, what's the new value?
57. 57.
57. The old value was 33. We're going to do that subtraction, which we've actually already done, right? That's 24. And then we divide by the old. So this is going to be 24 divided by 33.
It's a long decimal. It's 0.72727272.
On into infinity.
Yeah.
And that's where they tell us round your answer to the nearest tenth of a percent. Now this is, be careful. A lot of people will round it to the nearest tenth here and call that 0.7, but this is not a percent yet, right? How do we make this into a percent? Move it over 2 places. So that's going to be 72.72 point, yeah, on and on. And we want to round it to the nearest tenth, which is this place here. So what do we do with that 7? Do we round it up to 8 or do we round it down to just 7?
To 8?
Why?
Wait, no, it stays 7.
Stays 7 because the 2 is next to it, it's not half. So we're going to do 72.7%. And we don't have to keep going on to forever and ever. And that's why I decided to start doing the quizzes, is we can. It work? Now yours might be different. Be careful. Your numbers might be different than mine. So
Yeah, I know, but
okay.
I did everything you said, but my values were 60%, but were 30% and 60%. And 60 minus 30 divided by 30, just gave me 1. Put it 1, said it was wrong.
100%.
Right.
You have to put it as a percentage. So good. Check it. So yeah, if I put 0.72, it's going to mark that wrong because it wants the percent. And generally, you got to learn to look. They got the percent here because sometimes I want the decimal. So that's and I don't always catch it. So far doing good. Percentages.
Mm-hmm.
Okay. Okay. Actually, we get easier as we go. Shirt was originally priced at $40. The store has a 5% off sale. Is that going to get you out of your 5% off? It's not even worth going to the store, right? How much will you pay for the shirt, right, after the discount, not including tax, round your answer to the nearest cent? So, 2 ways we could do this, but what's the most direct way?
Multiply by the decimal. I mean, but we turn the percent to a decimal and multiply.
Okay, so 5%.
That would be 0.05 or just 0.5.
Which one?
Yeah, 0.05.
Yeah, because we have to move it 2 places, right? 1, 2. Now, when we multiply, what are we going to get though? We're going to get 5% off, right? We're going to get the discount. We're going to get what we're saving, which is okay. Then what would we do with that? Subtract it. So take 40 minus. But what if we wanted to get it directly? We take our 40 times, remember this is percent off, what would be the percent on? It would, excellent. So it's 100%. We subtract the 5%, and we could use 95% as our multiplier, or 0.95. So we take 40 times 0.95, we get our answer directly.
I see.
Again, the other way, multiply by 0.05, you've got your discount, you subtract it, and you also know how much you saved, right? Which is not much. What, $2? $4? 4 times 2, no, I think it's $2, yeah. So yeah, you either do 40 times 0.05, $2, but don't put that in because that's just your savings. So then you have to subtract the 40, which is 38, well, would be the other way, so cost of the shirt. But if we take, where's my clear button?
So we can just go straight to 40 times 0.95.
Yes, which is 38. Same price, same thing that we got by doing it the other way, which is, math is it. Here's the deal though, if you're in a store and they're, and hopefully having more than a 5% off sale, having a 40% off sale, the problem is a lot of people try to calculate that 40% off, and then they've got to subtract in their head, and oftentimes there's pennies involved or something. That's harder to do. Instead of multiply by 40%, what could you do? Multiply by 60%, and you would get exactly what you're gonna, and sometimes you know, at least you can estimate what you're gonna have to pay a little bit quicker. Okay, so just a little side trick. Again, it works either way, just less. It's always easier to, when you're subtracting a percentage from 100, right? Because you could do that, you know, 5 minus 100, 95. That's easy. 2% off on 40, that's a little, I mean, that's not too bad either, but you could see if you're in a store and you've got all these different prices, it's a lot easier to calculate it with the percent on. What's it gonna cost me? Okay, almost there. So we got, what, 3 more problems. We'll see these last 2 are pretty, kind of what we were more talking about. Okay, I'm gonna, oh, actually that helped going larger. I thought it would hurt it. Anyway, we might not need to write too much. Okay, so this is what we're going to take a look at is kind of getting back to chapter 2, which was linear equations. This one is going to be exponential type equations or percent growth. So we've got 2 job offers. Carlos does. They both have a starting salary of $56,000, not too bad. One, they're going to give an amount of a raise, $3,920 a year, every year. So that sounds good. The other guarantees a 6% raise each year. So then we're asked to complete these tables. So first of all, with this salary increase of $3,920, what are we going to be doing each year? We're going to start with the salary.
And add 3,920.
Right.
Raise a year.
Yeah, but we go from 1 to 5, so does that mean I have to just kind of keep adding and adding?
You can multiply.
Good. So that's our linear equation. So for this one, we're going to kind of think of it as a linear equation. We start with $56,000. Each year, we're going to add 3,920, and we'll multiply it times t. So then we take 5 times that, add it on, so we can fill all of these in, right?
Mm-hmm.
Okay. And let's maybe just do a few of them. I'll leave, you know, it's just kind of tedious calculations. First year's not too bad. I don't know why they couldn't do a round figure, like just give them 4,000. That's a lot easier to calculate, right? It's only $80 more. So 56, oh, not times. So that's our first one. $59,920. And I'll just do a check. There we are, we're good. And then this one.
Oh wait, you could click on those keys to check your answer?
I can,
Oh,
because I got the,
wait, no.
that's
the
you just got to be a teacher. They give you all the answers. You don't have to come up with the answers anymore. Yeah, so yeah, I know you would probably be
Wait,
nice.
so for the quizzes, can you give me like the teacher accessibilities so I can just check my answer like that?
That I can't do.
What?
I don't have the authority. I mean, I literally can't do that.
I know.
So we take the multiplication first, so that was 5 times 3,920, and then add the 56,000. So now, 5 years down the road, 75,600. Nice salary. and we just keep moving on, okay? Question is if you got a 6% raise, is that better, or which one would be the better job to take, right? So you could keep going with this. I'll let you, and again, your numbers may be different, so it doesn't really do me any good to go through. But what about a 6% raise each year? Now let's think of what we were talking about with percentages. So 6% raise, what would we multiply by?
0.06?
0.06 would give us what?
Oh, right, so that would, we would subtract 6 from 100, and that one we get, like, 94, right?
Are they subtracting it? Are they paying them more or less? 6% more or 6% less?
6%.
More.
More. They better pay me more, yeah.
Oh,
I've
so-
had jobs where they'll do a 6% decrease,
So
but
would that be 106?
it would be 106, yes. So that's the key part, is thinking that we're gonna get all our salary plus we're getting a 6% raise, right? So for down here, we wanna think of,
So that would be times 106?
yes, so 1.06, right? And whatever we start with is the 100%, so that's 56,000 times 1.06. And what we're gonna do is each year we multiply by 1.06. When you do repeated multiplication, what type of math operation is that? Right, 3 times 4 is repeated addition. That's like 3 plus 3 plus 3 plus 3. What if I wanted 3 times itself 4 times? 3 times 3 times 3 times 3. What would I write? I would write raised to the 4th power. So it's an exponent. So with percentages, yeah, we get exponents, so there's going to be a little t up here. So when I want to calculate the first one, I can just multiply and then there's a 1. Second time I'm going to have to raise it to the 5th power and then multiply. So I'll just use a basic calculator. So this time we're taking 56,000 times 1.06. Now, had we multiplied just by 0.606, we would get the amount of the raise. But this time, 59,360. 59,000. So we see it's actually a little bit less. He's making just a little bit less than he did if they were give the amount change. But what do you think is going to happen by year 5? Any guesses?
It's gonna increase.
It's going to be
a
bigger.
lot.
So always take the percent increase, because that's exponential. Exponentials start growing faster. So to do that one, we're going to take the amount of the raise, 1.06, and on this one, there's this x raised to the y key. I'm going to click on that, and then I type in the 5. That's going to take 1.06 to the 5th power. I'm going to hit equals, gives us this factor, and now I'm going to multiply it times 56,000. So after 5 years, this job is, oh, that's disappointing. I'm actually making less, but maybe it kind of does that because if you graph these two, you'll see 49,940 or 79,000. I transposed it all, didn't I? 74,940. 74,940. So it's a little bit less. Do you think maybe by year 10?
You make more in year 10.
So it's kind of like, of course, you might not like this job. We're going to leave after 5 years, so then you want to take the first one. But if you're going to be there for 10 years, it would better to take the 6%, right? And again, we just, and if you got a TI-84, it's nice you can kind of plug this in and it'll give you a table and all that kind of stuff. But one,
Can you go back to how you did, So when it comes to doing like for salary with 6% year raise per year for 5 years, how would you calculate that again?
So you need to use the exponent key on your calculator. So I do 1.06, use the exponent, and I did to the 5th power. What I want to do now is the 10th power, so whatever power you're using, and then I hit enter, and it gives me a decimal, and then I multiply it by the 56,000.
So say in my case, so so the exponent key, would that just be the pointing, this thing? Sorry.
It looks like a little chevron. That's put your finger down just a little bit. Yeah, that's your exponent key.
Wait, this one?
No, the one you had it on.
Okay,
Yeah,
this
that
one.
is it,
Okay.
but I couldn't see it. So yeah, 100,287. Okay. And we'll check it, that's good, and then we didn't do this one, but they're only making 9, so it's,
And then times, so then so in my case, that would be,
yeah, so you take that number times the starting value. So that's a kind of a comparison of linear versus exponential percent changes. Okay, so far so good?
Do you have any idea how to do the exponent or the power on a graphing calculator?
It's the one that has a little chevron. Let's see, it's called a chevron. I'll show you.
Okay. I would have
Let's
you
see.
just show me, but it's all good.
Where is my, oh, here it is. Oh no, this one doesn't work. Oh, that's my calculator. No, I thought I already. Well,
okay, so I think this goes in your.
Okay, I think I did it.
okay,
So, and then once I get that number, so 56,360 to the 5th power is 5.68 or whatever it was. And then you multiply that by 56,000. Okay.
Yeah.
Okay. We're good.
yeah, so we order of operations, we do the exponent first, so take the 1.06, raise it to the power, then multiply.
I think the decimal just threw me off. So
Yeah.
Thank you for that.
Yeah.
Sorry. Thank you.
And again, we can, but as long as you can see the process, that's good. Okay. So now thinking of what we just went through, this one's going to be more of a conceptual type problem. Okay. So notice each of these equations are 3 different savings accounts. So actually what I want to do, and then we'll have one more problem and then we're ready for work. Which part of these tells us the interest rate that we're getting in the savings account? Say this one, how much interest are they earning on their savings? Right, what did we do earlier when we had a 25% growth? We had 1.25, we subtract 1, we get a 25% growth. So what would we do with 1.05?
Subtract 1.
Subtract the 1.
About 5% growth.
You get a 5% growth, good. So this we can just see that's a 5% growth. How about this? 1.038,
3.8%.
very good. So just by looking at it. And what's happening down here? 0.85 minus 1.00, what are we gonna get?
Just the same, because
Decrease.
You're gonna get decrease. That's not a very good account to be in. They're losing 15%. So this is a 15% loss. So you subtract, it's the same thing, you subtract the one from it, 15% loss. So then, okay, so we kind of know that. How much money did they put into these accounts? That's right here, 900 into this account, 1,100 into this account, 5,000 into this account. Wrong choice. So account A is growing faster than account B. Is that correct?
Yeah.
Yes, that is correct, because we have multiple things. Account C has the largest balance in the year 2012. Well, in the year 2012, is that true? It's got,
No.
well, in 2000,
Account C, yes.
yes. So at the beginning in 2012, but you're right, as soon, because we're losing 15%, we'll probably be low. So this one actually is true as well, right? Which of the following statements are true? Yeah. C has the largest balance at the beginning. They have 5,000. The balance of account A is growing at a rate of 5% per year.
True?
True. And then the balance of account C is decreasing at a rate of 85% a year.
False.
Good. It is decreasing, but the rate is 15%.
If it was 85%, then really
That would be, yeah, you definitely better get your money out of that
That's-
thing.
That's literally financial, that's one of the worst debt I've ever seen.
Yeah, yeah. Although, that's about what was happening in the stock market last year. It's
So
become-
these first three are true, and then this.
Yes.
Okay.
Now, again, on yours, they have a way of randomizing. Your questions might be in different orders.
Yeah.
I think the values are the same for this one.
But, okay.
But the order of the question.
Yeah, it looks like an image that they put there, so they're not, so I'll do this, this, and this, but the questions may be a little different. But yeah, okay, so that's conceptual just from looking at it. And then we've got one more, and as you see, it's an equation. Okay, so we're given an equation. It represents value in dollar of a car T years after its purchase. Use this equation to complete the statements below. So the value of this car is what? And we have to select. Is it increasing or is it decreasing?
Decreasing.
Because how much is it decreasing?
0.06%.
Good. At a rate of, let's see, and again, you have to kind of select the percent. Yeah. So if we do percent, is it 0.06 or is it 6?
6?
It'll be 6 because 6%. If they wanted the factor, it would be 0.06. So good. So sometimes, where do we put? The purchase price of the car was?
35,800.
Exactly. So we always multiply by that what we started with, the 100%. So whatever number's there. And that's in dollars, not dollars per year, just dollars, because that's a starting value. Okay, so you can kind of see the kinds of questions that you'll be getting in the home. Oh, I didn't like something I did. Oh, percent per year. Okay, good thing I get another try. Okay, sometimes I just get, oh, I see an answer, I take it, look good, but it's 6% per year.
Decreasing?
Decreasing because the factor inside here is less than 1.
Oh, okay.
So if you subtract 1 from it, so 0.94 minus 1, you get a negative number.
Okay,
That's the
got it.
decrease. Good, yeah.
Thank you for asking that question. I was so confused. I was like,
Excellent.
what
Exactly.
the
If
hell
you
is
have a
happening?
question, there's more than one person that probably has that same question. All right, so that's our quizzes. And
So I kind of struggle with number 4 a bit just because I don't know what I did wrong.
what you might want to do, yeah, so it's just one of them there.
Well, actually all these 4 down here were also wrong.
Okay, so you might want to write down the question and then just on the, because you've got to go to the calculator and going back and forth might be part of the problem. Oh,
I have
you've
a
got
fiscal,
that.
I have a
Okay.
fiscal one.
And it might be, let's see, what do they say? Rounded to the nearest dollar. So they don't want the decimals. That may be, your answers might be correct, but they don't want the decimals in there. So just to round it to the nearest dollar. So on that one, you may have to round up and,
So I guess I was probably doing it right, I just,
yeah. Sometimes when everything's wrong, it's just, oh, I'm just not putting them in the format that they want.
and then for this one, it is the same thing, just like this plus that, and then times 5, right?
Well, no, you multiply by 5 first and then add it to 56.
Okay.
What other classes do you take?
English.
English, one, two.
One of them.
Oh, I was thinking we were in a different class.
I know, yeah, I think we talked about it last time.